Hello and welcome. This video will cover the digital multimeter available in the Electronics Lab. We got few models available now, which are the GDM394, which is the older model, and we got the 398 now. This video will cover the 398. So in here we are going to cover the GDM398 multimeter. We'll start first by identifying the different parts and buttons on the multimeter for your reference later. In here we got the LCD display, we got yellow and the blue buttons, we got the functional buttons, 4 of them in here, we got the rotary switch, which will be basically our selector switch in here, and we got the input terminals where all the probes going to be fixed. I'm going to cover the measurements based on the rotary switch order. So we are going to start with the first selection, which shows V, voltage, and DC is in black, while you can see a small AC sign in blue color. That means you can change always between DC and AC. The default value will be DC, which is always black. So all the black values will be the default ones. And auto range will be also the default range for the multimeter. If you would like to change it to AC value, we'll need to go to the blue range in here, which is basically by clicking on the blue button. And we got AC in here. You can keep changing between DC and AC using the blue button. With regards to range, which works basically in all the different options, by clicking the range, we are going to change between the available ranges. So clicking the range will change the multimeter from the auto ranging to manual ranging. Now, for example, we can get volts, and you can see the location of the point. Now, volts without any points, millivolts, and keep pressing, and this will go into loop, changing the accuracy and the range. If you would like to go back to auto range, you will need to click on range for a few seconds, and that will get you back to auto range. Again DC, and to change to that we'll click on the blue button. So the general functions all in black. To change to the blue one we'll need to press the blue button. For voltage measurement, always we'll need to fix the black wire terminal into common. So this is basically common here. Even in some multimeters common is written in red, black wire should go there. Likewise. Then, based on the selected option or the selected range, the red probe will go into the next appropriate terminal. In our case is V, voltage is here. So red will go into there. Now you can always see some small values in the LCD screen even without any connection. And the voltage, capacitance, and different ranges. This will be basically due to internal circuit, due to static voltage outside, and so. But if we get the terminals together, that should get us to 0 volt. As you can see here, the short circuit voltage is 0 volt, which could be a good idea to do it before testing low voltage values. Now I'm going to use the voltage to test a battery voltage, which you can get it in DC right now, 3.1 volts. Now if we flip the terminals, or if the voltage is negative, you can get negative sign in the screen, as you can see now. Again, if you are looking for AC voltage, you will need to change to the blue scale. You will need to know something before we move from voltage. The impedance, the input impedance of the multimeter for measuring voltage is very high impedance, and it goes to 10 mega ohms for normal ranges. In millivolts range will go up to 3000 mega ohms, which is very high impedance, but this will affect your values if you are dealing with high impedance circuit. With normal circuits you have no problem. If you ever have to go to that high impedance of the millivolt, you cannot use the auto range anymore. You will need to change to millivolt range in order to get the 3000 mega ohm impedance. Next will be the next selector switch selection is ohms in black, which will basically support measuring resistance. And again, if we do the short circuit, we should get 0, because the resistance of the short circuit is 0. We are getting very small value there, which is due to the probe's wires resistance. But if we get a resistor in, something like that, this is 150 ohm resistor. Now of course, my body resistance while holding the resistor like that will be in parallel with that resistance. But you can always use one side as a floating to get accuracy, or like fix the resistor on the table or on a piece of paper and get it measured. With this multimeter, we got a multi-purpose socket, which can be useful to measure resistance. It looks like this. So this is the multi-purpose socket, and you can see here we got a couple of connection options which we are going to cover. The part now we are doing, which is the resistance, and if you look into the blue options, we can do capacitance, diode, and continuity. We can move between these three blue options by clicking on the blue button. Now you can see here the value is in ohms for resistance. We click once, we get the diode, which is basically the second one. We click one more time, we get continuity and farad for capacitance, and then goes back to resistance. So this multi-purpose socket will always fix like that, where you can see the HFE readings, which we will come to it later in our next selection. So in the middle you can get R, you can see R and C there in the middle. There is R and C. So this will support measurement of resistance and capacitance. And for this case, we will need to fit the resistor inside the terminals, like that. Now we are getting the value of the resistance. This resistance, based on the color code, is 150 ohms. We are getting pretty much to that figure. In similar way, we can fix capacitance and change the range to capacitor, diode, change the range to diode, and capacitance in here, or resistance. We can use this for all the three purposes: resistance, diode, and capacitance. For continuity, normally we work with the probes. Again, black goes to common, red goes to whatever is this. So continuity normally is with ohms, because here the main selection is ohm. You can see ohm here, so the red terminal goes there. For continuity, the multimeter is going to give a sound signal if there is a continuity, which is basically very low resistance, similar to that, and will give you resistance value as well. So this sometimes you can use it to make sure that there is a connection in the wires. We can change the range. Next, is HFE, which is basically transistor beta value. Again, we'll need to get the multi-purpose socket in, and in this time you can see you have transistor connections on both sides, and this will support also SM transistors. You can see small n, small p. That means this side is for PNP transistors, and this side is for NPN transistors. I got one NPN transistor in here, which I will show you how to use it. We'll need to insert this 3 terminals in, and you will get approximate beta value in there. This will give you an indication if your transistor is working or not, but this beta value is not high accurate to use it for calculations. Always refer to your data sheet for the accurate beta value. Next on the range will be Hertz, which is basically for frequency selections. You can see in this Hertz that percentage mark in red, which was available also on voltage, and you can see it in current as well. You can get to that one always by pressing in here and the Hertz duty cycle. This basically will give you a duty cycle of AC signals. If it's basically you are measuring frequency, then you can do either Hertz, which will give you frequency. Pressing in here will give you duty cycle in percentage. Similarly, you can do that on a voltage signal and current signal, assuming all of them, of course, AC. Next will be the next 3 selections are all doing current. This is microamps, milliamps, and amperes. For microamps and milliamps, the connection will be, again, black is at common, and the red will be in milliamps, microamps. So microamp, milliamp, both terminal will be in here. Then we can measure a current value. You can see now it's auto range and it's going to microamps. We can always use the range to change between that, or we can change the scale altogether and get to milliamps. Now we get also the blue sign again here. The blue sign will change to AC, as you can see here, DC and AC current. So it depends on which kind of current you are measuring. You will need to make sure that you are selecting that. The multimeter will auto range the values, but will not auto change between DC and AC. If you have a DC current and you got the multimeter on AC, you will get wrong values, and vice versa. For amp selection, we will need to place the red terminal at the amps, which can read up to 10 amps. Now these maximum readings are decided by the fuses, and you can read information here about the fuses. Milliamps and microamps are fused via 0.6 amps. So the reading maximum will be 600 milliamperes. If you exceed that, you will damage the fuse, and the fuse will need to be replaced. Similarly, if you are doing amps, maximum will be 10. Just to give you an indication about the current, is not to be used for long time. So if you have a circuit working for hours, you cannot always connect this as ammeter in series. Otherwise, it's going to heat up and will start to melt down the terminals. So all the multimeter readings should be short and to give you an indication. The last one selection in the rotary switch is EF, which is electromagnetic induction. This is useful to find out the wires inside the walls or get an idea if there is a current passing through wire. So this is really for indications, and the values are not accurate. I'll show you an example on doing that. while doing electromagnetic field measurements, you don't need to connect any terminals. You will need to point the device, which you can see this arrow. This device will point to the wall, or let me just get it down. So this device will point this arrow to the wall, the socket, the cable you are testing. Something like that. I'm testing my laptop charger now, and you can see as it comes nearby, the value is changed. Some current passing in there till it gets, as it comes nearby, a current increase. So this is basically it for the selections. We'll cover the function buttons a little bit more in here. Let's get to the voltage selection. The yellow button can do two functions. The main function for it is hold, which is going to hold the value. If you click one time, you will get this capital H in there, and the value will not change. It will hold the value for you to note it down, to compare it with something else. That doesn't, it could be anything, but this will hold. Clicking again, the values will come again to real time. So hold and let go. If you press this for more time, you will get the backlight on, which can be used if you are working in a dark space. But that will consume a lot of the battery as well. Switching it off, again, keep pressing in that. The range, will cover the range as you can see in here. Volts, now millivolts, and always if you would like to go back to auto range, keep pressing for a few seconds, and we are out of auto range again. Max minimum value is going to give you the maximum value during your test. So for now, I get 1 millivolt as maximum, and it will not change till a higher value come. Minimum will give you the minimum value, which I'm getting minus 1.6 now, and again it will not change till a lower value came. To cancel this, you need to press for a few seconds. For the next one, which is REL, pressing one time will get the multimeter into the REL mode, which will be basically subtract the actual value from the stored value, which can be sometimes confusing. So always make sure you don't have this logo in. Pressing REL for a few seconds will switch on the data connectivity mode, which is not supported by this model, GDM398. So this sample will be there based on the internal setup of the multimeter, but there is no way to get the data out. Some other models, you can connect them via USB or RS232. So you will need to press again for 3 seconds to get the screen to its normal value. The fourth function is the duty cycle, which can be done while doing voltage, hertz, or current. The blue button always is going to change between the blue available options. In this case, we can change between AC/DC. In here, we can change from ohms to diodes, capacitance, and continuity. So this is basically it for the multimeter. It's a long video, but in order to cover all the functions or all the different signs you might see on the multimeter, this was required. Thank you for watching.